Hi there, this is Mrs. Denton, and in this video we're going to be learning about a trapezoid, specifically an isosceles trapezoid. Okay, so this is our first quadrilateral in the series that is not a parallelogram. Let's go back and look at a parallelogram real quick. Okay, so a parallelogram, ta-da, is a shape where both pairs of opposite sides are parallel. Both pairs of opposite sides are also congruent to each other. Both pairs of opposite angles are congruent to each other, and the diagonals bisect each other. These are the four properties that build up a parallelogram. Okay. Well, if you look at a trapezoid, we're missing some of these really important key properties. So let's get started and look at a trapezoid here. All right, got my ruler handy. I'm working on the centimeter side. Let's start with our exterior measures. I measure A to B. I'm looking at 5.5 centimeters. If I measure D to C, I'm looking at like 7.2. Whoa, that is the first time in this series that the opposite sides are not equal to each other. And that's because we're looking at a trapezoid now. A trapezoid is going to have a short base and a long base. It's a different shape, not a parallelogram. All right, let's check out these other sides. AD, I've got 3.4 centimeters. And BC, 3.4 centimeters. Now, this is happening because we are specifically looking at an isosceles trapezoid. Now, you've seen the word isosceles all year long. We've talked about isosceles triangles. And in an isosceles triangle, there are two angles that are equal to two sides that are equal to each other. So we're just like cutting off the top of that triangle to build this trapezoid. So you do have a pair of congruent legs of the trapezoid. All right. Well, more to come from that shortly, okay? Now let's take a look at our diagonals here. AC, I'm getting 7.2. And BD, I'm getting another 7.2. So there is some symmetry happening here. Because this is an isosceles trapezoid, we've got a line of symmetry running down the middle that makes the left and right sides a matchup. Well, that also is why our shape is so centered, why there are equal parts to the shape. If we were looking at a non-isosceles trapezoid, let's see if I can draw one of those. Short side, long side. Okay, certainly not isosceles. We have one long leg and one short leg. Well, look at what that does to the diagonals. It gives me one really short diagonal and then one really long diagonal. So this is just a general trapezoid, not an isosceles trapezoid. And all the time I've been working with geometry, we've never seen a regular trapezoid on our SOL, so we spend most of our time thinking about the isosceles trapezoid because this line of symmetry is so handy. Okay. All right. Now let's check out our diagonal measures here. A to E. A to E looks like 3.1. 3.1. Okay, well, if this is 3.1 and the whole piece from A to C was 7.2, 7.2, let's just do a little subtraction. 7.2 take away 3.1 leaves me with 4.1 for the other piece. So we had 3.1 here. That would leave you with 4.1 from C to E. Let's confirm. 4.1. Now here we could get a little off with our measurement. If I move my ruler just a little this way, it looks like 4. So here's another situation where I want my measurements to all line up. If I say it's 7.2, then these two pieces need to sum up to 7.2. All right, let's go this way. Well, let's not. Hold on. Let's use some symmetry. If this pink line of symmetry is running through the shape, then 3.1 should flip across, and 4.1 should flip across. So BE, 3.1 centimeters, DE, 4.1 centimeters. Okay, so we're done with our side measures. Let's switch on over to our angle measures. Something to note here maybe is you have one line of symmetry. Okay, now let's check out our angles. Starting with AEB, starting up here at the top again. Okay, line up my protractor. I'm going to need a lot of help reading this one. It's a very small figure and a very big protractor. So line that on up. I know I'm reading the obtuse measure. That's an obtuse triangle, so I'm starting here. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. I'm just shy of 130. I'll line it up just right. I might be at 130, 126, 125, something in there. I'm going to go with 126. 126. Okay. Take a minute. Think through how you can use that 126 to find the other three angles here at vertex E. I got to show you something cool that just happened. Check this out. I went ahead and added up these bigger angles. 27 and 77 add for 104. 27 and 49 add for 76. Well, y'all, if you take 104 and 76 and add them together, you get 180. Whoa, 180, you know that's an important number. Why is that important? That's important because let's go back to these lines. They are parallel to one another. And if you have a set of parallel lines, you know you're going to have consecutive interior angles that have to add up to 180 because they're supplementary. Also, check this out. 27 and 27, alternate interior angles that are congruent. Another set this direction, 27 and 27, alternate interior angles that are congruent. That's so important. Jot that down. That's happening. But what about this way? How frustrating. 77 alternate interior to 49. What's up with that? Why are those not equal to each other? Guys, they're not equal because these lines on the left and right are not parallel. With a trapezoid, we only have one set of parallel lines. So this alternate interior angle property only works along the parallel lines. Man, we could have gone about this in so many different directions, but I love the way it works out. What a beautiful puzzle. Let's go down here and highlight our isosceles trapezoid properties. Okay, both pairs of opposite sides are parallel. That's a big no this time. Only one pair of opposite sides are parallel, not both. Just the top and bottom in this picture, not the left and right. Both pair of opposite sides are congruent. No, not in this situation. Only one pair of opposite sides are congruent. Both pairs of opposite angles are congruent. That's a no. 104 and 76, not congruent. 104 and 76, not congruent. Only one pair of opposite angles congruent? Nope. All four angles are congruent? Nope. You don't have any of these opposite angle congruencies that have been present in the parallelograms. You do have consecutive interior angles that are supplementary, though. If you want to kind of link that down to your properties, that comes from the parallel lines. Diagonals are congruent? That is a yes, and that's because we have this line of symmetry in here. Diagonals bisect each other? That's a no. 3.1 and 4.1 are not equal. Diagonals are perpendicular? That's a no. We don't have 90-degree angles at the intersection. Diagonals bisect the angles in the figure? That's a no. The 76 has not been split evenly. So man, let's compare this property list to one of our parallelograms. If you go back to the parallelograms, these four properties hold true for every parallelogram. A rectangle, a rhombus, and a square are all the parallelograms. None of those four properties hold true for the trapezoid. These are all for parallelograms, and none of them hold true for the trapezoid. These are your trapezoid properties. One pair of opposite sides parallel, and then for your isosceles trapezoid, one pair of opposite sides are congruent. Had this not been isosceles, a lot of this repetitive measurement would not work out because we wouldn't have that line of symmetry. All right, let's do some practice. Got this picture? What's the measure of angle R? That's it. Not much given to you. You've got some algebra in the picture, and we want to know what's the measure of angle R. So check out their pictures. We've got angle R is obtuse, angle U is acute. So they're not equal to each other. Absolutely, I cannot say that this obtuse angle and this acute angle are equal to each other. Not happening. So what's something else that can happen? Let's go back and look at our notes. Check out where they are. Upper obtuse, lower acute, boom. Consecutive interior angles. We've got our parallel lines, and these are consecutive interiors. We know that consecutive interior angles are supplementary due to that set of parallel lines. So the algebra I'm going to set up is 15x plus 8 plus 7x minus 4 add up together to sum total 180 degrees. Combine your like terms, solve for x. Okay, I solved for x and I got x equals 8. Now my question says, what is the measure of angle R? So I'm not going to circle 8 and assume I'm done. I've got to go back. I've got to substitute 8 in for x. Angle R would be 15 times 8 plus 8. Well, 15 times 8 is 120, and 120 plus 8 is 128 for my final answer. Okay, next example. If math, M-A-T-H, is an isosceles trapezoid, okay, go ahead and put your tick marks in there, and the measure of angle A is 60 degrees, what is the measure of angle X? Now, think about isosceles. If you have to go all the way back to an isosceles triangle, please do. Isosceles means two equal sides, which builds two congruent angles because it's got that line of symmetry in there. So if this is a 60-degree angle, we put that line of symmetry in, we've got another 60-degree angle here. And pull this over here also. We're seeing this in both problems. If our parallel lines build consecutive interior angles that are supplementary, then angle H has to be 120 degrees. Man, this property is really coming in handy up here. I feel like we should go back to G2 and do some practice. Be good practice to see that again. Final example for you. Which of the following quadrilaterals is not a parallelogram? All right, I want you to draw a parallelogram and think it through. Parallelogram has two sets of parallel sides. Okay, a rectangle. Draw yourself a little rectangle. A rectangle has two sets of parallel sides. Draw yourself a trapezoid. It doesn't have to be isosceles, but isosceles will work. Trapezoid only has one set of parallel sides. Draw yourself a square. A square has two sets of parallel sides. And draw yourself a rhombus. A rhombus has two sets of parallel sides. So a trapezoid is the only quadrilateral that is not a parallelogram. That's why it doesn't follow all of the same rules that we've been studying for the rest of the chapter. All right, guys, get some practice in. Come see me if you need anything, and happy studying.